Greetings, I'm Abhishek Dokra from BCA Group 2 and my group members are Akshata Paul, Atanu Chakraborty, Nitish Kumar Parwa. Our project title is Expression Recognition and Satisfaction Survey. Our project is divided into three modules, which is extraction of embeddings, the training of model, and the actual recognition. During the extraction of embedding phase, we loop over each image in the dataset, and what happens is all the embeddings from the images are extracted and encoded in a file. That is a pickle file, and the labels, which are the folder names, are also saved in a different pickle file. Our model is a support vector classifier model. So when we train the model, it will actually classify the images into different labels. So for example, if we have pictures of people being happy under the happy folder, under a folder named happy, what happens is the model will classify all these images and put them under the label happy, which will help us during the recognition phase. Now during the recognition phase, what we do is we turn on our camera and we take each frame one by one. These images are also enhanced in terms of brightness, so even if you're in a low light area, it will still work to an extent. So once we are done, we do the same thing that we did with the dataset images. We extract the embeddings and then we get our model to compare them. So the current embeddings are compared to the embeddings inside the model, and it will predict the expression based on that prediction. And we also have database connectivity, so at the end of the program we'll also upload the current expression survey to the database, and it will also display a pie chart, which I will show you in a bit. Right, so let's proceed on with the practical. Let me just so as you can see, we have three modules, three buttons here to execute each module. So I won't go about executing the extract embeddings module because it will take a lot of time, since our dataset has around 1500 images, and since it has to loop over each image, it will take a lot of time, and I'll just skip it. But I've already done it previously, so we can just proceed on with training the model. You just click on it and you wait for the command, and it's done training. Now we can proceed on with the actual recognition. Let me just turn on my PAMP server. So my PAMP server is on. Now we can proceed on with the actual recognition. Here you are. As you can see, it will I'll talk to you about this frame count in a second, but for now let's look at the expressions. It's jumping between three expressions that we've actually trained the model for, which is neutral, happy, and frowning. Now right now it's frowning. If I do right now it's neutral. If I frown, then it will stay up to frowning, and if I smile, as you can see, it's I mean the model hasn't been trained properly, it seems, because it can't classify between neutral and happy. So for now we'll just skip it, and as you can see, there are different counts for each expression. The maximum number of faces counted till now, number of faces currently in the image, and this frame count is for convenience. Once it reaches 100, this data will actually be inserted into the database, and once I press Q, you get the actual pie chart. 100%, so out of 100%, it was 84.5% neutral, 2.2% happy, and 13.2% frowning. Let's move on to the database. That was my mistake. Right, let's log in. Browsing to the table, and as you can see, today's date is 33 2020. 33 2020. These are the times and these are the counts at that particular time. This is our project, and right now we still have to work on the optimization and the accuracy of the model, and we'll be increasing the dataset so as to make the dataset actually be able to differentiate between more emotions. Thank you.